So here we have a triangle ABC with the condition that 2 times cosine of A times sine of C equals sine of angle B. Then we need to show that the triangle must be an isosceles triangle. So let us begin. Now, in order to show that the given triangle is an isosceles triangle, we have to use the law of cosine as well as the law of sine. So let's specify both of the two laws. So we have a triangle ABC. Then the sides opposite to angle A, B and C are represented by the letter A, B and C in lowercase. Then the law of cosine states that the cosine of angle A in terms of its sides is given by b squared plus c squared minus a squared over 2bc. Similarly, we can define cosine of angle B and cosine of angle C. Then the law of sine states that the ratio of side A to that of sine of the angle opposite to side A, so that angle A, this ratio is equals to the ratio of side B to that of sine of the angle opposite to B. And it's also equals to the ratio of the third side to that of sine of the angle opposite to side C. So we have here we are given with the condition that 2 times cosine of A multiplied to sine of angle C, so that's equals to sine B. Now we'll substitute the value of cosine A with 2 multiplied to b squared plus c squared minus a squared divided by 2bc multiplied to sine C. Now, to find out the value of sine C, we'll consider this particular ratio and we'll suppose that let this ratio be equals to a common constant and we are going to call it 1 over lambda. Then we can represent sine of angle A as A times lambda. Sine of angle B will be equals to B times lambda, and sine of angle C will be equals to C times lambda. So we're going to substitute these values here. So sine of angle C, so that's C times lambda. So this is equals to sine of angle B, which is B times lambda. Fine. So we can factor out lambda from both sides, and we can also factor out 2 from the numerator and the denominator. And we can rewrite this as b squared plus c squared minus a squared divided by, we can also factor out the c from the numerator and the denominator, divided by b, which is equals to b. So cross multiplying b, we're getting b squared plus c squared minus a squared equals to b squared. So we can cancel out b squared from both sides and we are getting c squared equals to a squared. So which will be equals to C, which gives us C equals to A. Now we know that whenever 2 sides of a triangle are equal, then this means that the triangle ABC must be an isosceles triangle. So triangle ABC is isosceles, hence proved.